Heavy haulage pushes the limits of logistics, moving colossal, extraordinary loads with precision, power, and engineering brilliance. The shifting of the world's largest single-train crude distillation column was a remarkable engineering operation. Measuring 2.5 meters long and weighing 250 metric tons, this massive unit was relocated to its berth with precision. The CDU is the refinery's primary unit, separating crude oil into essential fractions like naphtha, diesel, and kerosene. The extendable trailer, equipped with an electronic forced steering system developed by Manac, is a highly advanced transport solution designed for heavy and oversized loads. This trailer can be lengthened to adapt to cargo of different sizes, offering remarkable flexibility for operators. Its modular structure ensures stability and optimal weight distribution, even when carrying long and heavy materials such as concrete beams, steel components, or construction modules. A standout feature of this trailer is its electronic forced steering system, which enhances maneuverability and control during complex operations. The system synchronizes the steering of multiple axles to follow the movement of the tractor precisely, minimizing tire wear and improving safety. This is particularly valuable when navigating tight corners or restricted areas where conventional trailers would face difficulty. Furthermore, the trailer is equipped with a remote control that allows the operator to execute precise maneuvers in confined spaces. This function provides exceptional accuracy and safety during loading, unloading, or parking operations. With its robust design, adaptability, and smart steering technology, the Manac extendable trailer with electronic forced steering represents a new generation of heavy transport equipment. It not only increases operational efficiency, but also ensures safer and more environmentally responsible logistics for specialized transportation tasks. Shortly after 9 a.m. on May 2, 2017, a massive convoy of 33 vehicles departed from a manufacturing facility in Schenectady, New York. One of these vehicles, measuring over 345 feet in total length, carried an enormous 375,000-pound turbine. This was the first of 3 multi-state transports destined for a newly constructed combined cycle power plant in northeastern Pennsylvania. The operation, led by Edwards Moving and Rigging, represented one of the most challenging and logistically complex heavy hauls ever attempted in the region. Safety was always the #1 priority. Each morning began with a detailed meeting that included utility companies, private escorts, local and state law enforcement, and even railroad personnel. Every person involved in the project had to fully understand their roles, responsibilities, and contingency procedures. The philosophy was clear. If one person had a concern, then everyone had a concern. Months of meticulous planning, engineering, and permitting preceded the move, ensuring that every turn, bridge, and elevation change was carefully reviewed before the convoy hit the road. The Edwards team brought both innovation and determination to the project. When conventional routes were impossible, they scouted alternatives, sometimes negotiating directly with local residents to cross private properties safely. In one particularly difficult section, the crew had to navigate under a bridge only 14 feet high, even though the load stood at 19 feet. To achieve this, they backed the transporter up an interstate ramp and crossed to the opposite side of the highway before continuing eastward. A key element of success was the use of an Aspen dual-lane expandable transporter, powered by 3 Kenworth C500 tractors. This trailer could expand from 14.5 to 19 feet wide, allowing it to safely distribute weight and meet bridge permit requirements. The total permitted load weight reached an astonishing 913,227 pounds, with dimensions of 345 feet in length, 19 feet 6 inches in width, and 18 feet 8 inches in height. The permitting process alone consumed hundreds of hours, requiring constant coordination between Edwards, local jurisdictions, and state departments of transportation. Engineers analyzed every structure along the route, and agencies cooperated beyond normal business hours to finalize approvals. After traveling 228 miles, the turbine reached the plant area, where Edwards used its J&R 700-ton gantry and 175-ton PowerLink system to lift and transload it onto an 18-line Goldhofer trailer with AD drive. This system allowed the load to climb grades up to 11% and maneuver independently inside the facility. The entire project was completed flawlessly, without any injuries, equipment damage, or schedule delays, showcasing Edwards' unmatched expertise, coordination, and innovation in heavy transport engineering. The transportation of a giant power transformer across eastern Iowa represented a major logistical challenge that required exceptional coordination and expertise. The heavy load, weighing several 100,000 pounds, was mounted on a specialized multi-axle trailer and hauled by powerful tractor units. To ensure that the 70-mile journey was completed safely and efficiently, Kinco's bucket truck escort crew provided critical assistance throughout the entire operation. Their mission involved identifying and clearing all potential roadside and overhead obstacles that could hinder the convoy's movement. Using hydraulic bucket trucks, the Kinco team carefully lifted power lines, communication cables, and traffic lights to allow the enormous transformer to pass beneath without damaging any infrastructure. They also trimmed overhanging tree branches and monitored clearance at every intersection and bridge along the route. Communication between the escort crew, utility companies, law enforcement officers, and transport drivers was constant and precise, ensuring synchronized actions at every step. The convoy moved at a slow and controlled pace through rural landscapes and small towns, often requiring temporary road closures and traffic management. Kinco's crew demonstrated exceptional professionalism and situational awareness, responding quickly to challenges such as narrow roadways, uneven terrain, and unpredictable weather. Their skillful coordination minimized disruptions to local traffic and maintained the safety of nearby residents and workers. Beyond simply supporting the haul, Kinco's bucket truck escort operation showcased the company's commitment to safety, reliability, and teamwork in the field of heavy transport logistics. The successful completion of the 70-mile escort across eastern Iowa illustrated how careful planning, clear communication, and specialized equipment can make even the most complex oversized transport operations possible. Through their efforts, Kinco helped deliver critical infrastructure safely and efficiently across the state. Maxim Crane Works and Crane Rental Corporation successfully executed an extraordinary, long-distance heavy haul project, transporting 3 sections of a liquid natural gas storage tank from Oklahoma to West Virginia. The operation covered nearly 8,000 miles in total and involved moving close to 700,000 pounds of equipment. Each journey presented unique challenges caused by ongoing road construction, paving, and changing route conditions. The shortest trip spanned 436 miles, while the longest extended to 724 miles.
According to Alan Ashlock, president of the Southeast region, the greatest complexity of the operation lay in logistics. The company's skilled team engineered a safe transport method, obtained permits and organized escort vehicles across multiple states and municipalities, and carefully arranged staging areas for overnight parking of the massive loads. The 2 end sections of the LNG tank measured 53 feet in length, nearly 16 feet in width, and almost 15 feet in height, each weighing approximately 270,000 pounds. The center section was 32 feet long, 15 feet in diameter, and weighed about 145,000 pounds. To ensure stability and even load distribution, the components were secured using suspension cables on Crane Rental's state-of-the-art dual-lane transport trailers. Despite the enormous scale and complexity, all 3 tank sections were delivered safely and efficiently within just 34 permitted days, highlighting the company's exceptional planning capabilities and expertise in overdimensional logistics.
In 2011, Crane Rental Corporation successfully executed the transportation of a massive cold box weighing 319,000 pounds and measuring 150 feet long by 19 feet wide. The equipment was destined for a state-of-the-art air separation facility on the west coast of Florida. Upon arrival at the port, the ship's cranes carefully hoisted the cold box and placed it onto an 18-axle dual-lane Goldhofer trailer. This initial configuration allowed for highway travel but presented major engineering challenges at several bridge crossings along the haul route. The bridge capacities along the corridor were not sufficient to support the full weight of the cold box using the 18-axle configuration. Due to the bridge design, there was a risk that the entire load could bear on a single span or set of columns. To comply with Department of Transportation regulations and protect the bridge's structural integrity, Crane Rental engineers developed a unique solution. The load was transloaded from the 18-line Goldhofer trailer onto 4 separate 6-axle Goldhofer modules, one positioned at each corner of the cold box. This innovative arrangement spread the weight evenly across multiple beams and columns during bridge crossings. Before movement began, a safety meeting involving 64 participants, including local and state police, utility companies, and crane rental personnel, was held. Each bridge was inspected before and after the crossing by Richardson Engineering to ensure safety. During the first bridge crossing, traffic on the interstate highway beneath had to be completely halted for 12 minutes, while the road above was closed for a full 24-hour window to allow for trailer reconfiguration and safe passage. For the second bridge, there was no available roadside space, and extended closures were not permitted. Crane Rental performed the trailer swap at a nearby truck stop, staging pre-configured Goldhofer units in advance. To rejoin the road, the crew quickly laid plastic mats to help the massive load cross the median. After clearing the bridge, the cold box was reassembled onto the 18-line trailer, a process that took 3 hours and involved precise sequencing, lowering the trailer onto metal stools and repulsion. Throughout the journey, traffic lights and utility lines were raised, and police escorts ensured public safety. The project demonstrated Crane Rental Corporation's exceptional planning, coordination, and technical expertise in executing one of Florida's most challenging heavy-haul operations. The impressive road transportation of a SpaceX Falcon 9 rocket booster from Port Canaveral to the test launch facility. After returning from a successful mission, the booster is carefully moved for additional testing before being refurbished for its next flight. The Falcon 9, known for its reusability, is a 2-stage rocket designed and manufactured by SpaceX to transport satellites and crewed spacecraft into orbit.
Falcon 9. All right, there's the paddles.
Due to its enormous size and weight, the transportation process requires precise coordination. The rocket is securely mounted on a specialized multi-axle trailer pulled by a powerful truck. Escort vehicles, such as the one seen in front displaying an oversized load sign, ensure road safety by clearing the way and alerting other drivers. The convoy moves slowly, navigating wide turns and overpasses with extreme caution.
I guess it remove the legs.
This overland journey highlights SpaceX's commitment to innovation and cost efficiency through the reuse of rocket components. Each recovered booster undergoes inspection, testing, and requalification before being assigned to a new mission. The careful transport of the Falcon 9 booster demonstrates not only advanced engineering, but also the logistical precision required to make rocket reusability a practical reality. On October 24, 2021, a large-scale loading operation took place at Port Newark, New Jersey, where scrap metal was being loaded onto the Turkish-flagged bulk carrier Manac Voyager for its voyage to Turkey. The port was bustling with activity as towering piles of scrap metal consisting of crushed vehicles, steel beams, and other recycled materials awaited transport. Massive green material handlers equipped with hydraulic grapples lifted heaps of metal debris and dropped them into waiting dump trucks. These trucks, in turn, transported the material closer to the dockside, where another crane loaded it onto the ship's open cargo hold. Each movement was carefully coordinated to ensure efficiency and safety, as workers managed traffic and secured the loading area. The operation showcased the port's critical role in the global recycling industry, serving as a major hub for exporting American scrap metal to overseas markets. This material would later be melted and refined in Turkish steel mills to produce new steel products, highlighting the sustainable cycle of metal reuse. The site of the Manac Voyager docked against the pier, surrounded by heavy machinery and mountains of metallic waste, represented the intersection of industry and sustainability where waste from one region becomes a valuable resource for another. The 60-ton ram body for the YC-60 hydraulic impact pile hammer was transported to Bangladesh for a major bridge construction project. After the milling process was completed, the massive steel component was transferred to the plating and painting workshop for corrosion protection and final finishing. The YC-60 hammer, known for its high impact energy and precision, is designed to drive large foundation piles deep into the ground, ensuring stability for bridge structures. Once the finishing procedures were done, the ram body was carefully loaded onto a heavy-duty trailer using overhead cranes and secured with strong chains and steel brackets. It was then transported to the port for shipment. In February 2021, the completed YC-60 hydraulic impact pile hammer was delivered to the construction site in Bangladesh, ready to support pile driving operations for the bridge foundation. This successful delivery marked an important milestone in preparing critical equipment for one of Bangladesh's key infrastructure projects. An impressive heavy transport operation was organized. This type of transport, known in German as Schwertransport, is used for moving extremely large and heavy industrial components that are impossible to carry with conventional trucks. The entire combination has a total length of 53 meters, runs on 24 axles, and weighs around 528 tons, including the load and the vehicle itself. Such operations require exceptional preparation, engineering, and coordination. Before the journey begins, specialists carefully study the route to ensure that bridges, roads, and curves can support both the weight and the size of the transport. The numerous axles distribute the total mass evenly across the surface, preventing damage to the road and ensuring stability. Each axle is steerable, which allows the long vehicle to turn smoothly around corners despite its enormous dimensions. The blue tractor unit serves as the main power source, while the red section behind it supports the transported structure, possibly a heavy transformer or an industrial machine. The driver and the accompanying crew constantly communicate to control steering, speed, and positioning. Heavy transports like this typically move at very low speeds and often travel at night or during weekends to reduce traffic disruption. Escort vehicles drive ahead and behind to block roads temporarily and guarantee safety for other road users. This impressive operation clearly demonstrates the precision, teamwork, and advanced technology required to move massive cargo safely and efficiently across long distances. Here in Newcastle, United Kingdom, Sarens carried out the assembly of one of the largest cranes in the world, the SGC-120. This massive ring crane was built for the beach project, where it would handle heavy jacket structures for offshore use. After several weeks of preparation and assembly, the crane was finally ready for load testing before being handed over to the client. The SGC-120 is one of the most compact yet powerful cranes ever constructed. It has a lifting capacity of more than 3,000 tons, and its low ground-bearing pressure allows it to be erected on-site with minimal civil work. The assembly process began with the installation of the 45-meter ring, which serves as the crane's rotating base. The ring was placed on load-spreading steel mats to distribute the weight evenly and ensure stability during operation. Once the foundation was complete, the main frame was built, followed by the installation of large deck panels on top of the frame. The team then mounted hydraulic winches and power packs, which are essential for reliable and precise lifting and lowering of heavy loads. After that, the two back masts were raised one by one. Temporary bracing was used to secure each structure as the assembly progressed, and the crawler crane was detached after completing the first mast to continue with the second. With both back masts standing, the Sarens crew installed the connection links between them, ensuring structural rigidity. The next stage involved loading 36 counterweight containers, each weighing 100 tons, filled with locally sourced materials. These massive blocks balanced the entire structure and stabilized it during heavy lifting operations. Afterward, the team performed the reeving of cables, using smaller guide wires to pull thicker steel cables through the pulleys. Once completed, they connected the bridles to the main boom, which had been pre-assembled on the ground. The 130-meter-long boom was then carefully lifted and installed onto the crane, followed by tensioning the bridles using the winches. The pre-assembled hook block was also reeved and attached to complete the lifting mechanism. Finally, the SGC-120 underwent a full load test to verify its performance and safety. Despite its immense size, this crane operates efficiently even in restricted spaces such as offshore platforms or nuclear power plants. With its compact design, impressive lifting power, and advanced engineering, the SGC-120 truly represents one of the greatest achievements in modern heavy lifting technology. In 2014, Sarens successfully performed the loadout of the massive Clare Ridge DP jacket, weighing 23,000 tons, at Kvaerner Verdal in Norway. The operation began with the use of 36 axle lines of Kamag self-propelled modular transporters to carefully lift and move the enormous steel jacket from the assembly area toward the quayside. These SPMTs, controlled with millimeter precision, ensured the even distribution of the structure's enormous weight during transport. Once positioned over the barge, a computer-controlled system using 200-ton strand jacks slowly pulled the jacket onto the vessel. At the same time, a set of 600 cubic meters per hour ballast pumps automatically adjusted the water levels inside the barge tanks to maintain stability and balance throughout the transfer. This precise synchronization between the SPMT's strand jacks and ballast system was essential to prevent tilting or structural stress. The successful loadout demonstrated Sarens' engineering expertise in handling one of Norway's heaviest offshore jacket transports.